Hey everyone, this is Matt Menyes, and today I'll show you what I've been working on for the past 2 weeks. My large language model capstone project. Let's go. I've deployed 3 large language models across my local computer network. These models, which are running across 3 Linux virtual machines, are running directly on my computer's hardware instead of running it through the internet. So this means that any interaction I make with them is offline, private, and free of charge. To deploy this infrastructure, I'm using Proxmox, a virtualization platform that allows me to run multiple VMs and containers in a physical computer. But here's the twist. Instead of running everything on one computer, I'm running them across 3 physical computers. And I'll explain why that's the case. So each of these 3 nodes is hosting a single Linux virtual machine running my AI models. My reason for using 3 nodes instead of 1 is pretty simple. I want high availability. Here's why. So let's say my AI models are running on only 1 computer. That's fine by itself, but what if that computer fails? How can you use your offline AI with a failed computer? You can't. That's why I'm using a cluster of 3 computers. They are all running 1 virtual machine each, but if one of them shuts down or fails, Proxmox detects the failure and automatically migrates the virtual machine to any of the 2 other healthy nodes. But how about the storage? Proxmox has a storage clustering feature called Ceph, where it partitions the node's physical drives into a shared storage pool, meaning anything stored in the Ceph partition is replicated across the 3 nodes by the second. So when node 1 goes down, the local hard drive storing VM100's virtual drive also goes down. But since the storage is replicated across 3 nodes, the VM's virtual drive is readily stored in a Ceph partition of node 2's hard drive. Therefore, as VM100 migrates into node 2, it should have everything it needs to boot up into its current state. Sounds pretty cool, right? Well, let's head over to my computer right now and see how this works in real time. So what you're seeing here is my Proxmox GUI, and right here are my 3 nodes. Each one is running 1 Linux virtual machine. And so what I'll do today to test my high availability is that I'm going to turn off node 1. And as I turn off node 1, we're going to observe what happens to this virtual machine, VM100. It's going to migrate into either node 2 or node 3, most likely node 2. But you know what? Let's see what happens. Okay, so I'm gonna go to node 1, and I'm gonna hard shut this down by pressing this shutdown button for a long time. Okay, so shutting it down. As you can see, there's nothing left in the screen. Okay, so node 1 is now shut down. Let's see what happens in my GUI. So it's gonna take a while. It might take like a minute or 2 or 3, but it's gonna take a long time. It might take longer than usual, but eventually we'll see that this virtual machine, VM100, will either migrate into node 2 or node 3. But for now, let's wait. Okay, so you saw there in real time that VM100 has successfully migrated into node 2. And let's see if it really is successful by checking the computer here. Okay, so we can actually use the virtual machine. Let's type on my password. I'm using one hand, that's why it's really slow. Okay, so I'm in, and it took like, 5 minutes. So it takes that long, but Just wait it out, and eventually it will move into either healthy node. So you see what happened there. The virtual machine running in node 1, the one that I just turned off, has successfully migrated into node 2. So that's what's meant by high availability. If one node fails, then the other backup nodes can still take over its processes, preventing major downtime, which is what enterprise networks need today. The hardware phase is only half the battle. I will now show you the fun part of this project. I will run my AI models on my computer and interact with them using LLM, which are all running locally. I'll go over how the software works under the hood, but for now, I'm excited to show you the fun stuff. So what I will do is that I will prompt one of my AI models in LLM. Here are the 3 available IP addresses of my LLM interface. I will use the first one, 142.232.241.211, port 30,002. Alright, so here we are in the LLM interface, and as you can see here, I have my Llama models ready to use. I have DeepSeek, Qwen, and Llama, but I will use DeepSeek because it is the fastest model I have. And so I will prompt it by something like, what can I eat for lunch? Okay, so it will take time to generate a full answer because the models are running on virtual machines with limited resources. But again, it is still running offline, the chats are still private, nor am I getting charged a fee because the AI is deployed locally across my 3 classroom computers. Okay, so DeepSeek is done generating an answer, and here it is. It's a pretty good answer. It has suggested 10 things that I can eat for lunch. So I'd say it did a pretty good job generating an answer. And the next thing I will do is I will test if the interfaces also work on the other IP addresses. So I will use 212.430,002. Okay, yeah, the LLM interface works. And I will use the third IP address, 213.430,002. Okay, so now we know that the LLM interface works across 3 IP addresses. So you've seen the fun stuff, but how does it work? How are both my Llama models and LLM working together to serve its users? Well, all of this is possible thanks to Kubernetes. Kubernetes is an open source system for automating deployment, scaling, and management of container applications such as Llama and LLM. It works by grouping containers together into logical units for easy management. On the other hand, containers are a standalone software package that has everything needed to run an application. So things like the code, the libraries, the settings, and other dependencies that the app needs are all stored in a container. You can think of it as a shipping container that has all of the items inside, but these items are what make an application like Llama work. Containers may be similar to virtual machines in concept, but they are functionally different. Containers are lightweight and resource efficient because they are typically deployed on the host operating system, whereas virtual machines are bulkier in size and run their own operating system separate than that of the host, which overall requires even more hardware resources. So going back to my project, I will show you at a high level where my applications are running. So I'll start by going to the command prompt, and I will SSH into one of my virtual machines. So SSH NAT 241.211. I'll type my password, and here we are. We are in one of my virtual machines that are running my Kubernetes. So if I type micro k8s kubectl get pods, okay, this is going to take a while. As you can see here are my pods. These are the units that are running my application, like my Llama and my LLM. And if I type micro k8s kubectl get services, SVC, and as you can see there, these are my services that are running my applications. So Llama service and LLM chat service. And notice here, you see port 30,002. that corresponds to port 30,002 on my IP addresses. So that means that the Lobe Hub service is running on port 30,002 on my IP addresses. And if I show you one more thing, microKDS kubectl get pods. microKDS kubectl get nodes. Okay, so here are the nodes. These are the virtual machines that are working together to keep my Kubernetes applications up and running. So KDS1, KDS2, and KDS3. So that's a little bit about my project where I have deployed 3 AI models across a node cluster. If there's one thing I've learned about this project, it would be that, well, AI is incredibly helpful. Sometimes a bit too helpful to a point where it will do everything for you, which is I admit, my case in this project. But even then, AI has its own limits, especially in troubleshooting, that it can't fix everything for you. Human intervention is still needed to address specific troubleshooting scenarios in the IT industry. And yeah, that's it for my project, and I hope you learned something today.